So students, our today's topic is determination of sulphate content of deodorants and antiperspirants, and for this we will use indirect method. So sulphate content of deodorants and antiperspirants can be determined by using atomic absorption spectroscopy employing the use of excess of barium chloride solution. Why we use barium chloride? Because barium chloride precipitates the sulphate present in deodorants and antiperspirants as barium sulphate, and when we use excess of barium chloride, the unreacted or free barium remains in the solution or supernatant, and that can be determined by using atomic absorption spectroscopy. And requirement for this would be given sample of deodorant or antiperspirant, concentrated HCl, standard solution of barium chloride, say 200 ppm, and for that purpose we will use barium chloride dihydrate, which is having molecular weight equal to 244 grams per mole, and we need 5% potassium chloride solution prepared by dissolving 5 grams of KCl in 100 ml of distilled water. And then we need standard solution of sulphate, say 1000 ppm, which can be prepared by using anhydrous sodium sulphate, that is Na2SO4. So first of all, I am starting with preparation of standard solution of barium chloride, and we are going to prepare 200 ppm standard solution of barium using barium chloride dihydrate. So for that we need to calculate the weight of barium chloride that we need to dissolve. So as the atomic weight of barium is 137 grams and that of barium chloride dihydrate is 244 grams. So I can say that 137 grams of barium is equal to 244 grams of barium chloride dihydrate. Now from this I can write that 1 gram of barium would be equal to 244 divided by 137, and this will come out to be equal to 1.78 grams of barium chloride dihydrate. So it means that if I dissolve 1.78 grams of barium chloride dihydrate, which will contain 1 gram of barium, and or I can say 1000 milligram of barium, then upon dissolving 1.78 grams of barium chloride dihydrate in 1 liter of water, the concentration of barium in the solution will be equal to 1000 ppm. So if 1000 ppm contain 1.78 grams in 1 liter, then 200 ppm will contain 1/5 of that amount. So it will be equal to 1.78 divided by 5. So this will come out to be equal to 0.356 grams in 1 liter. So if I dissolve 0.356 grams of barium chloride dihydrate in 1 liter, then its concentration would be equal to 200 ppm. And suppose we do not want to prepare 1 liter of the solution, and we just want to prepare 500 ppm of 500 ml of 200 ppm barium solution using barium chloride dihydrate. So as 1000 ml or 1 liter contain 0.356 grams, so 500 ml will contain 0.356 divided by 2. This would be equal to 0.178 grams of barium chloride dihydrate. So I can say that if we dissolve 0.356 grams of barium chloride dihydrate in 1 liter, then its concentration will be 200 ppm of barium, and in order to prepare 500 ml of solution having concentration of barium 200 ppm, we need to dissolve 0.178 grams of barium chloride dihydrate in 500 ml of distilled water. So to prepare 500 ml of 200 ppm solution, I can say that dissolve 0.178 grams of barium chloride dihydrate in 500 ml distilled water. This has standard stock solution of barium having concentration 200 ppm. Next is preparation of standard solution of sulphate. Standard, say we are using 1000 ppm of standard sulphate solution. So as the molecular weight of sulphate ion is equal to 96 grams and that of sulphate is equal to 142 grams, or sodium sulphate is 142 grams, and we are using anhydrous sodium sulphate. So I can write that 96 grams of sulphate ion is equal to 142 grams of sodium sulphate. So 1 gram of sulphate ion would be equal to 142 divided by 96, and this will be equal to 1.479 grams of sodium sulphate. So I can say that if I dissolve 1.479 grams of sodium sulphate anhydrous in 1 liter of distilled water, then it will be having 1 gram of sulphate ions. So this will be the standard stock solution of sulphate having concentration of sulphate 1000 ppm. Then we will prepare standard sulphate solutions of different concentrations, say 25 ppm, 50 ppm, 75 ppm, 100 ppm by dilution of the 1000 ppm sulphate standard solution using distilled water. Next is the preparation of sample solution of deodorant or antiperspirant. So for that, take 10 ml of, or say known weight, known volume of the deodorant or antiperspirant sample, and we will add 1 drop of concentrated HCl to make the solution acidic, and 1 ml of 5% KCl solution followed by 10 ml of 200 ppm barium solution. And we will dilute it to 25 ml by adding distilled water and shake the contents and allow to stand overnight. Why? Because when we will add barium chloride to the sample containing sulphate, sulphate will be precipitated as barium sulphate. So to settle the precipitates of barium sulphate, we will keep it overnight, and then after keeping it overnight, we will collect the supernatant. So precipitates of barium sulphate will settle out at the bottom, and we will collect the supernatant, and we will test the supernatant for the amount of unreacted barium. Then we will repeat the same procedure by using standard sulphate solutions of 25 ppm, 50 ppm, 75 ppm, 100 ppm in the same way, and we'll leave them overnight. How? We will also treat standard sulphate solutions by using barium chloride so as to precipitate barium sulphate in them, and we will also collect their supernatants. Then next step is taking the absorbance readings. So for that purpose, we will fix the wavelength of the instrument at 553.6 nanometer, and will measure the absorbances of different sulphate supernatant solutions having concentrations 25 ppm, 50 ppm, 75 ppm and 100 ppm using nitrous oxide acetylene flame. Then we will measure the absorbance of the supernatant prepared from the solution of deodorant or antiperspirant. Then we will plot a graph between absorbance along x-axis and concentration of sulphate in ppm, absorbance along y-axis and concentration of sulphate in ppm along x-axis. So we will get this sort of graph. So along the x-axis concentration of sulphate is there, and along the y-axis absorbance is there, and please note that absorbance here we are measuring at 553.6 nanometer. So at the bottom there will be different concentration of ppm, this say 25 ppm, 50 ppm, 75 ppm, 100 ppm and so on. This picture I have used only for the representation purposes, although here concentrations are different. So I have used this just to make you clear that what sort of graph we will get. Then after plotting the graph, we will determine the absorbance of the supernatant of the deodorant or antiperspirant sample, and we will extrapolate that absorbance value onto the x-axis, and the point at which it will extrapolated line will meet the x-axis or concentration axis will give you the concentration of the sulphate in the deodorant or antiperspirant sample. So this is how you can determine the concentration of sulphate in the given sample of deodorant or antiperspirant. Thank you.